Chapter 4, Day 2, we are going to look at domain and range of functions and relations, and we're also going to look at independent and dependent variables. Now here's kind of a model I want you to think about. Functions are kind of like vending machines. You input money, you type in a code, and out comes your snack or beverage. So in other words, remember in a function that each x value has only one exact y value. So when we look at this, we input the money, we type in the code. The code is our x, and what comes out, every code only has one exact snack that gets dispensed. So your code that you type in is like your x value that you input, and exactly one snack output is your y value. So another way to think about functions. So just to review again about relation versus function. A relation is just any set of ordered pairs because there's a relationship between the two variables. And so if we look at are these functions or not, we can see that none of the x's repeat. Each x value, each place here has only one exact number of points assigned to it. Here's that same track scoring information with a graph. And again, notice it passes the vertical line test. Anywhere you would draw a vertical line, you would only touch your graph in exactly one place. Now, of course, I probably drew those lines a little bit too heavy, but if we draw a vertical line, we will only touch our graph once, any vertical line. And in a map, notice each of these only has one arrow coming from it. So yes, these are all function. For each x value, there's only one exact y value assigned to it. Now, if I had a different arrow coming off of this 4 over to 2, now, no, not a function, because the x value of 4 has two different point totals assigned to it, and that can't happen. So we don't have that in this case, but it's would not be a function if we add the arrow 4 going to 2. All right, so again, it's a function if the x values don't repeat and it passes the vertical line test. So, again, a little bit more review about discrete versus continuous. Discrete is separate points, individual points, not connected on a graph. The points are separate, and we can count those points. Compared to continuous, continuous points are connected, making a line or a curve, and it is measurable. So are these discrete or continuous? Well, these are individual separate points, and I can count them, so this is discrete. And it happens to be a function. I can tell it is a function because the x's don't repeat. So it's a discrete function. Should really write that underneath it, so we don't have any confusion. So it's discrete, and it's a function. It's a discrete function. Okay, if we look at the next one, you can see there are some points on this graph. There are some points, but they're connected. Because there's an infinite number of points in between there, we can't count them. So this is a continuous, and it is a function because passes the vertical line test. The next one is also continuous because you can see there are actually even points on there that are connected. And again, it passes the vertical line test, so this one is also a function. And last but not least, this is discrete. These are individual points I can count. So again, discrete is countable, individual separate points. Now, this one is not a function. Oh, let's not use that color. This is not a function. And the reasons it's not a function is because if I draw a vertical line here, I will hit 2 of those points. So that's a little bit more review. We want to keep going back through these ideas as we move forward. So today we're going to work on domain and range of a function from a table or a graph. And we're going to try to work on starting to identify the independent and dependent variable for a given situation. Now, these questions right here are not listed necessarily on your homework assignment, but these would be optional for practice. Okay, so, all right, so we go back. We always want to go back and review as we go forward because some of this is very important and continues to carry forward. So, a function is a relationship between two variables such that each value of the first variable, that is our x, is paired with exactly one y value. That's what makes it a function. The x value never repeats, so it passes the vertical line test. And remember, for each x value, there is only one y value, and that's what we talked about at the beginning with the vending machine. So now we get into the domain of a function is the set of all possible x values, which are our inputs. That's what we input into the equation of the function. The range of a function is the set of all possible y values, which is our output values. So domain and range. Now, we're going to try to find these from both tables, graphs, and maps. So your domain, remember, is the set of all x's. Oops. X's. So what are my x's? I have a 1, a 3, and a 5. So my domain, I'll just use a D for it, is the set of numbers of 1 and 3 and 5. My range for this function is a set of all y values. So here's a y value, a y value, and a y value. So my range is the numbers 3, 6, and 12. So I did it with that set of ordered pairs, but that's really the same as this t-table. So what I want you to do is I'd like you to try this one right now, pause the video, and see if you can list the domain, which is a set of all x's, and the range with the set of all y's. So if you did it correctly, your domain for this function is 3, 5, 8. And your range for this function is -2, 2. Oh, that is not quite right. Your domain, I think I had a different question I was working on here. So this is actually, yeah, I added another one in here I totally forgot about. So let's try that again. So our domain is the numbers right here. So these are our domain values right here. But we don't just circle them and put an arrow like that. We actually list them. And we usually list them in order from smallest to largest. It's not wrong if you don't do it that way, but it's usually the proper way of writing it. So our range then would be the y values, -2, 0, 5, and 9. So domain, range, x's and y's. It's pretty simple when you work on it in terms of a set of ordered pairs or a map, but it gets a lot trickier if you have a continuous graph. These discrete ones are fairly simple. So I'm going to do this one next with you. So this is our domain, and we are looking for the set of all x's, or inputs. This is what we're putting in. This is our x values. We're putting in a -4, and it goes to 2. Okay, so our x's would be -8, again listing them in order, -4, 4, and 5. So these are our x's. Our range is our y values. That's what comes out. -4, you put in a -4, out comes 2. You put in a -8, out comes 1. So 2 and 1. But again, we try to write them in order if possible, from smallest to largest. Now, we don't list the values more than once, okay? We only need to list them one time, even if they appear 5 times. And going back to this one, your turn, one more time. Give me the domain of this function and the range of this function. Pause the video and then see if you got it right. So 3, 5, and 8 is your domain, and your range is -2, 2, and 7. Again, notice we don't list them more than once. So, domain and range of discrete. Now let's look at domain and range of continuous function. Here's where it gets a little trickier. Because now, when we look at our domain, remember that's our x's. Well, we have an x value right here. That's an x value of 1. You have a point right here. You have an x value of 2. You have a point right here. You have an x value of 3. And at 4, and at 5, and at 6, you have nothing past here though. So your x values do not go past 6. But they also are not any smaller than 1. So you have to kind of think about this as like a number line inequality. And our x's go from 1 to 6, like on that number line. And if you notice, the points were both shaded in. So just like when we did our inequality work, our x values are between 1 and 6. They are less than or equal to 6, and they are greater than or equal to 1. So that's the domain. It's a lot trickier when it's continuous because we don't only have a value at 1 and 2, we also have a value in between 1 and 2 at 1.5 and at 1.1 and all kinds of other values on that line. So now let's work on the range. The range is the y values. So the y values, if you look at this ordered pair, there's a y value right here at 1 and at 2 and 3 and 4 and 5 and 6, but nothing past the 6. So again, this is like a vertical number line, and your y values are between 1 and 6. So they're less than or equal to 6, greater than or equal to 1. Again, if those circles were not shaded, then you would not have the equal with your inequality. So let's see if you can take a look at and try this next one right over here on the right. See if you can figure out what your domain is. Remember, that's your x's. And then figure out your range. Pause the video, try the domain, and then start the video again. So your x's never get bigger than 1, but they also never get smaller than -1, 2, 3, 4, 5. So I believe my x values here are between -5 and 1. They're less than or equal to 1. They're greater than or equal to -5. So again, you're looking at this as sort of like a number line, and your graph is only between those values on the number line. Right there to there. I'll highlight it here. Okay, that's as far as your graph goes on the x-axis. Now see if you can do the range. So take a look at the y values on that graph and see where they go, from where to where. Pause the video and then see if you got it right. So your y values never go lower than 0 right here, and they never go above this value, which is 1, 2, 3, I believe, if I'm counting that right. So my y values, the smallest they are 0, and the largest they are is 3. So they're less than or equal to 3, greater than or equal to 0. And last but not least, we'll try one more. This one's a little bit trickier because notice that these are arrows on the end. Okay? Those are not just points. So these are arrows. These are arrows. So now when we talk about our domain of our x's, we have points here, 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 but it's going infinitely in this direction, even though it's going up, and it's getting smaller and smaller and smaller and smaller and smaller. So in this case, our domain is all real numbers. That is the symbol that means all real numbers. So when you have arrows on lines like that, they go infinitely in both directions. So now if we take a look at our y values on this graph, our y values, here's a y value of 0, of 1, of 2, of 3. You have a y value of 4, 5. They keep going up, but they also keep going -1, -2, -3. They keep going down. So the y values are also going up and down in both directions with this line. So again, it's all real numbers. And you can use the words, or you can use that symbol, double bar R. So practice these, think of them as horizontal and vertical number lines, and see what values you have in between. But in this case, you keep going. You keep going in both directions because of that arrow. All right, last thing we're going to talk about, or at least get started on, is independent versus dependent variable. The independent variable is the input of the function. Of a function. Oh, this is where it goes, the input. Independent variable is the input, and the dependent variable is the output. So again, what we put in is the x's. It's the x value of the function, and the dependent variable is the y value of a function. So what happens is the value of the dependent variable output depends on the value of the independent variable. Out. So what comes out depends on what you put in. So think back to the vending machine. What code you put in, okay, that's what affects what comes out. So what comes out depends on what code you put in. Here's another example. A Little Caesars pizza costs $5 each. We talked about this another day. The total cost right here, the total cost depends on the number of pizzas you buy. So what do you put in? You put in the number of pizzas, and out comes the cost that you're going to have to pay. So the total cost depends on the number of pizza you buy, or the cost depends on the number of pizzas. So your independent variable is the number of pizzas, because the total cost depends on. So that's your dependent variable, because it depends on something else. So these can get kind of confusing at first, but continue to work on trying which depends on. When it says total cost depends on, that means my cost is my y value, and my number of pizzas is my x value. So when I put in 1 pizza, my cost is $5. I input 2 pizzas I'm purchasing, and out comes one exact cost, $10. 3 pizzas, 15, etc. Here's an example of a discrete function. It's discrete because you can count the number of pizzas. You wouldn't connect the pizzas on the graph, or you wouldn't buy 1.1 pizzas or 1.111 pizzas. You can only count them, so it's discrete. It's a function because for each x value I input, I only get one exact y value as an output. In other words, if somebody else comes up to the counter at Little Caesars Pizza and wants 2 pizzas, they're not going to pay a different price. They're going to pay exactly one price. So for 2 pizzas, it's exactly one price all the time, and that's $10. Okay, here's another example. Aaron babysits and makes $8 per hour. So the amount of money that Aaron earns depends on. So the money she earns depends on the number of hours she babysits. So the independent variable, what you are putting into sort of the situation or story, or if you wrote an equation, you could write an equation that the amount she earns is equal to 8 times the number of hours she babysits. So the independent variable is the x's, or the number of hours she babysits. And the dependent variable is the money she earns. All right, here's a couple more examples just to get some more practice on this. Identify the independent and dependent variables. A painter must measure a room before deciding how much paint to buy. So, try to write the statement. The amount of paint that he has to buy, so the amount of paint depends on the size of the room. So, which is the dependent variable? The paint that is bought depends on the size of the room. So, the amount of paint to buy is the dependent variable, and the size of the room is what you input to get the amount of paint that you buy. Okay, so you try the next one. Pause the video, see if you can figure out which depends on the other. The cost to ship a package is determined by its weight. So the cost that you pay depends on the weight. So again, the cost is what depends on. So the cost is the dependent variable. So the dependent variable is the cost, and the independent variable is the weight. Hopefully you're starting to understand these a little bit better. Let's try the next one together. A veterinarian must weigh an animal before determining the amount of medicine to give. Okay, so you can't just give the same amount of medicine to the same size animal. So the amount of medicine depends on the animal's weight. So and I usually like to write it first. So the amount of medicine or medication depends on the weight. So again, when you write it out, then like highlight or circle the amount of medicine depends on. That's the one you know is your dependent variable. So your dependent is medicine, the amount, and your independent is the animal's weight. And last but not least, you try this one. Pause the video and then start again to see if you got it right. Okay, the cost to buy each movie ticket is $7 plus a processing fee of $2. So, your cost of the movie, going to the movie, or the cost of the movie tickets depends on what? It depends on the number of tickets you buy. And maybe the cost of the movie tickets might be easier for us to say the total cost depends on. So again, the total cost depends on the number of tickets you buy. So the total cost is our dependent variable. And our independent variable is the number of tickets. Okay, that is the end of day 2, working on domain and range of both discrete and continuous functions, and starting to work on and look at what are the independent and dependent variables, the input and the